Jij bent aan zet. Welke stappen zet jij voor de toekomst? Blijf je op bekend terrein? Of ben je een pionier? Welke toekomst creëer jij? Capgemini. Get the future you want.
Hello and welcome. Today I'm going to talk about API first architecture. This is actually it's not a new topic. We are doing this for quite a long time. It's now API. It used to be web services from the WSDL world. So we used to create WSDLs. We used to share the WSDL between different clients. In Java, .NET, everywhere we used to create clients and server stubs to reduce the boilerplate code. But it has been evolved in last few years quite a lot, and there are standards and things available which can help basically your DevOps team or your Scrum team to adopt this and work with it quite nicely. Before we go ahead, who I am? My name is Shubham Dasgupta. I come from a very beautiful city in India called Kolkata, and that's not Taj Mahal, this Victoria Memorial. And I live in another beautiful city in Netherlands, which is Utrecht. I do speak and blog quite regularly. I try to, at least. You can find me in all the tech channels, and all the code that I'm going to use today will be also published in my GitHub repository. So I'll share the link at the later on. So without further ado, this is the agenda today. I'm going to talk about the traditional route that most of us follow and how it differs from the API first approach. Then I'm going to talk about OpenAPI specification, OAS, and then how that we can use to speed up your development, testing, and integration process. I'm going to show you code samples and how to do stuff around it. First of all, API. API is everywhere. If you are doing IT, you cannot unhear and not use this in your daily life. From beginning to end, nowadays we only talk about APIs. It has been evolved from a simple API to microservices, bounded context, having sessions, etc., etc., etc. But when we talk about this and when we build something such core of our IT or of our for our clients, we always follow a very traditional route where a requirement comes in, the functional analyst and the business analyst guys sit together, talk through it, decide how many APIs they need, what kind of UI they will build on it, or what kind of other clients will actually try to call these API. And then it comes to the Scrum team, or if you're following a waterfall model, the architecture team. They will go into it deep, look at the technical aspects of it, and define such and such APIs. Then it will go to a development cycle. It will be developed. It will be deployed. Then the testing will comes in, check the specs again, do the integration testing, check everything is working fine or not, and then it will go to the other integration side, whether it's an UI or other clients UI. But this adds quite a lot of feedback loops. So if there is something goes wrong in the testing, it comes back to the development, and your integration side is waiting on it. Or if you are facing some issues in integration, for example, the UI was showing a checkbox, so it needed a Boolean value back, but it was actually coming back as a string, and they didn't really thought about it. So it comes back again so that you can actually put that as a Boolean value in your API response. And this goes on, and sometimes the code and development also go back to the requirement or your architecture team to think about how we can better manage the downstream requirements and wishes in a much more structured way. What it brings is longer feedback time. It brings waiting time for everybody, basically. It poses a very huge impact on your testing time because it comes in a very later phase. The specs and the integration side has not been tested before you go to deployment. It also introduces integration delay, and the developer experience is amazingly bad. So every time after 3 or 4 sprints, this person is again doing the same API, changing it from string to Boolean, which is in a way pretty frustrating can be for a developer, because he or she has been done that for like 3 sprints ago. So what can we change to make this a better flow? As I said, this is not new. We are doing this since WSDL, but we were doing this in a WSDL area only from the server stuff and client stuff way, and it was only bound to the backend code. But API first approach right now looks at the complete picture from development to testing to integration. And what that brings is that your requirement goes to a design team first, where this design team can be in your waterfall model, the architecture team, or your Scrum team itself, where they sit together and define the specifications of this API as the very first step. So they talk about how it will look like. What is the endpoint? Is this an HTTP method get or a post or a put or a delete? How does my request object will look like? How will it be in the header side? Are there any security applied to these endpoints? What is my response object? What are the types of those response objects and request object you are expecting me to define? And lots of other stuff, the versioning, where it will be deployed, etc., etc., etc. Once you have that specs ready, the optional step is you can create a mock out of it. I say optional, but normally if you do the mocking, that makes your life a little bit more easier from the integration and the testing side, because then they can create the test specifications and the integration code using that mock itself, when your code and your development and deployment can go on parallelly. So once all of these boilerplate tasks are ready and your code is also deployed, they can switch over from mock endpoint to the actual endpoint itself. So it brings quite it brings down the feedback loop quite heavily, because you are now going back from your design team to requirement. If there is any changes, the rest is actually you talked about it, you decided at the very beginning. So the biggest gain is feedback time, which was a negative point in the first approach. The time to market is very high, because you define your APIs and you send it to all of your team who are responsible for testing, integration, and development. So they are all working parallelly. So the parallel work is very huge. Then you have a clear abstraction of different tasks. So your design team is more focused on how to design this properly, the mocking it properly, and all your other teams are working on that specification itself. Your team efficiency high, and definitely it's going to reduce your cost. So that's more or less the approach of doing API first. I would like to actually have a poll to see if you are using API first approach in your project. And if yes, then I would like to know. To make it a little bit interactive. I mean, these virtual sessions are so boring. Cool. I think I have more or less a 60-40 response. Cool. Then it should be quite easier for you to understand the concept that I just said. And then let me move on to the second part of it, which is basically the Open API specification. Open API specification is also not new. They say it was earlier known as Swagger, but it is still Swagger. Their logo is still Swagger. So it is Swagger, and actually they changed from 3.0, the version. They change it and they call it Open API specification, and they define the standard of defining REST APIs. It is a language agnostic way to define how you design your APIs and how you publish your APIs. I'm going to show you how it all works out and how it looks like. Open API gives you 4 different ways actually to work or create your API. One is an online version. There's an editor.swagger.io. I'm going to show you that in a bit. There's an npm module. You actually can. It's an open source thing. You can install it and you can run it locally. So it'll basically pop up this editor swagger.io locally on your laptop, and you can actually work there. There's a Docker module also available. So if you are not really interested in doing all these npm installation on your laptop, you can actually run it via Docker module. So the Docker will host your Swagger editor. And there is a last one, which is actually a cloud version of it, is the Swagger Hub. I'm going to show you that as well in a bit. Let's see. Where is my browser? There it is. So this is editor.swagger.io. On the left-hand side, it gives you a YAML or a JSON way of defining your APIs. This is a YAML way to define it. I don't like a lot of curly braces around it. Much easier to read, so I converted it to a YAML. But if you are not really interested to do this, you can actually convert this to a JSON as well if you want. What you get on the right hand side is what you define. So the APIs you have, what kind of HTTP method it is, what kind of parameters you have to put, what kind of responses you expect. So you can also define your example responses inside your API definition. Also, you can define all your error codes, which can be generated from it. It also has a Swagger Hub version. Let me see. Swagger Hub. It's a little bit slow. The Swagger Hub actually have, it is a paid version. So the free version, you do not have all the facilities that the paid version gives you. If you check in their tools, you will actually see that there's a difference in what are the different aspects of it and how much do you pay for it, what is the difference about it. But it gives you similar ways to define your APIs and check what it is actually looks like. It gives you some extra feature of exporting it, sharing it, and also generating code for it. It gives you a dashboard where you can define more than multiple APIs, and you can link them with your GitHub repository. So any change you do, it can actually it actually syncs to your GitHub repository at the backend. That feature you never get in the online version or the Docker module version, where you really need to copy paste your the definition to your YAML file and self do the check-in. Before I go into the next slide, I have another question actually. Let me see. How can I open that poll? Are you familiar with Swagger? Oh yeah, 60/40 is on a yes side. People using it open API first approach on a yes side, 60 and no side now. Okay, so a lot of people are familiar with Swagger. 90% are familiar with Swagger. I'm quite glad that you are, because that gives me much more easiness to explain the next section of it, and I don't think I have to go in much deeper about it. So if you see the first line, it defines what is basically the version of your APIs. Right now it is on 303, if I'm not wrong. Yeah, it's on 303. I defined it on 3.0, so that's not really an issue as such. And then you define an info area where you have your title, description, your contact definitions, and where you get the license part of it. You also define your servers. This is quite important when you're doing a mocking, and when you have an actual environment, you can actually put multiple servers there. So your mocking server, your development, your test, and your production or acceptance, excuse me. So when people are consuming it, they can choose which servers they want to consume it. And the Swagger API also, the UI also gives you to test your APIs from here. So you can choose which server you want to call to test your APIs. There are tags available. I highly recommend you use this. I was not really convinced. One of my colleagues from our project, he convinced me to use it because it actually gives you much more visibility to see how your APIs are segregated. So when you're defining one YAML file for your particular microservice or service, it might have multiple endpoints. So your API has to be segregated somehow for easiness of read. And later on, you can also use these tags to generate or control the generation of your code later on. I might show you that later on as well. Then comes the path section where you define an endpoint or a path, and then you define basically the HTTP method, and then what kind of response you expect, and if it is a post or a put, what kind of request body you expect. You see here is a ref. Since you're quite familiar with it, the ref is basically a component which we define somewhere at the end of the YAML file. So these are basically, think of it, your model definitions. So these are the objects that will be used by your APIs as a request and a response. You can define your request response objects, you can define your error objects, you can define your security objects. Everything is possible to do it here. And also it makes you easier to reuse it. So your endpoints are reusing all of your things as well. You also use operation ID here. It's quite important because when I'm going to show you the generation, this operation ID plays a very important role because this operation ID will be used to define your controller method. So I'm going to generate a Spring Boot server with this specification, and you will see all of these operation ID are used as this controller method name, basically. So make sure you use this as a unique one so that your APIs doesn't. And by the way, when I say make sure, you can also validate your OpenUI, your YAML definitions using the OpenUI CLI. That I'm going to show you a little bit as well. So I am not going to spend more time on this anymore because 90% of you are quite familiar with it. But on a gist, YAML defines or JSON defines your API specifications. You have all your endpoints with your response request objects, your error definition, your and your stop definitions as well. One nice thing I'm going to show you at the very last about the Swagger Hub. So if I want to create a new one API in Swagger Hub, it asks me for a template. At the very end, I'm going to talk about how you should adopt or how I think you should be adopting the OpenAPI specification or contract first approach or API first approach in your project. One of the steps is define your styles, and defining styles is defining your template. The template tells you which all common objects are there and what kind of things that your client kind of imposes on your API definition. Like you always need to have a tag, or you always have to have a same error object coming back, or a different a set of error codes that you need to always use, or a security level restrictions that you are always using OAuth with a specific key and value pairs. So that actually you can use in your template. And let's say if I do that and make it a visible public, it'll create the API for me. So the Swagger Hub is quite powerful in here, and in that respect, that it gives you a skeleton of your API from the template itself. And you can do that with the npm and the Docker module. So that's one of the good part about Swagger Hub. Moving on. So I talked about this. You have info, you have servers, you have tags, you have paths, define all your endpoint, you have components defining your response, error, request objects. Pretty straightforward. The documentation is very handy and very well written. So I ask you to do check it out. If you type in OpenAPI specification, you'll land up here, and you have all the stuff to read about and learn about how you can actually use this in your project if you are not familiar. The 20% who said no. So now the part about OpenAPI generator. Now that you have the specification, remember I showed you the flow where you have a requirement, then it comes to the design team where you actually design and mock it. So let's say that part is over. Now what? I was saying that everybody can start working parallelly, but how will they work parallelly? There comes the part rule of OpenAPI generator. OpenAPI generator, by the way, is not part of OpenAPI specifications. They say that in their GitHub repository quite clearly. OpenAPI specification, the Swagger Hub, also gives you some kind of generation of code, but that's very static because you have to do that on their UI itself, and then you get a download of the code, then you can use it inside your actual code base. But OpenAPI generator gives you a much more flexible way to generate and use your code. There are different ways to use it. You can use Maven plugin. You can use Gradle plugin. You can use Cake, SBT, and Bazel as well. The right side, you see the number of clients they support, starting from CC Hash to Angular, OpenScript, Object-C, REST client, Kotlin, you name it, they have it. They have also server stubs available for almost all languages, from CC Hash to Node.js, Java, Spring Boot. I'm going to show you the server stuff of Spring Boot. I'm going to show you an API client of Angular. I'm going to show you an API client of Native. And I'm going to show you the CLI part as well. The CLI is quite important, well, quite handy, to be honest, because when it comes to generation, it's very customizable. When I say very customizable, read as you have 20 parameters to play around with. So when you need to really know what you want to use to generate the code as such. But it's not so complicated. 1 or 2 tries, it'll give you a code itself. And I'm going to show you how you can use the code generation without passing any parameters as well. So you see the API documentation. I'm going to show that part a bit. OpenAPI list. Is it, by the way, readable? I'm going to look at the chat very quickly. If you're saying no, okay, I see a lot of thumbs up. So, okay. If not, Stein told me that you can put it in full screen mode, and then it becomes bigger for you. But yeah, I'll leave it up to you what suits you better. So this is the CLI. The list command tells you which all clients and server stubs, documentation, schema, and everything you can use to generate this. So I have a small OpenAPI YAML file here, the one I was showing just a minute ago in the editor. You see, this is the same thing with this, all the components and all the endpoints here. So what I'm going to do is I'm going to try to generate a documentation. I've never done this before, so I hope the demo gods are with me today. Generator -i is my file. -g is what I want to generate. So let's say I'm going to generate an HTML. Hello? Oh, it's not generator. Okay, sorry. Let me see. Come on. Generators. So, okay, so it's a nice, actually, bridge. So this is the website of the OpenAPI generator that I'm right now talking about. They also have a very extensive way of defining everything. So the documentation is quite nice. So generation. Generate. Whoa. Okay, sorry. There you go. So I just now generated something which is an index HTML. Let me see how that is. Where is so it generated an HTML with zero CSS in it. So probably I have to use some more additional properties to make it useful for me. But this is how easily you can generate it. And if you really want to know the different properties the HTML gives you, you can try config help with the -G and the language or the thing that you want to generate, and it will give you back all the options that you have to make it beautiful for you. Basically, it's very useful that I can also generate. I think MySQL is one of the schema, MySQL schema. So I'm going to generate MySQL schema as well. What this gives you all the files that are needed for your database to set up. So you have a provider, you have a service, and you basically can add your schema directly. So you can also generate your schemas file from this opening API CLI. It's quite handy. Even though you're using the Maven node or any other way of integrating it, this gives you the very useful information of how to use different additional properties, what are they used for, and you actually can play around with a bit to know what exactly your actual settings are. So I find it quite handy, and I do suggest if you are using this, check it out as well. Then I'm gonna show you the servers and the clients. So first, I'm going to show you the server. This is a simple Spring Boot application. I have a repository. I have a couple of repositories. I have some service classes, and they are connected to a in-memory H2 database. And the magic happens here. So I'm going to make it a presentation mode. I hope it'll be readable for everyone. I don't know why my laptop is slow today, but I am using the OpenAPI generator Maven plugin to generate the Spring server. The generator name is Spring, so you specify which generation you want. You specify where to find your YAML file. You specify some other properties like where to create the model and the API packages. You can also specify whether you want to use the delegate pattern. I use it because I find it quite useful, but yeah, it's up to you. The Java 8 specification is for your date time classes. It is not about the language specification. The code will be generated, and it'll generate your code if you do a clean compile, and it'll generate in your generated sources, and you can refer from there directly. So if I go back to a non-presenter mode, and run clean compile, it will generate all the code. So it is running now the plugin. And once it is done, which is pretty slow, I really need to see what is making this all so slow. So once it is done, it creates the model classes basically with all the definitions. What is the JSON property? What is the proper data type for it. And it also creates the API. There will be one interface and 2 classes per endpoint. You basically need to, when you open it, it already tells you from the annotations and the definition itself that what you want to implement. So for my side, I actually created a service class, a annotated class, which is implementing the delegate class. And the delegate class actually defines all your endpoints. And the controller is also generated for you. So I'm not going to generate or write the controller. So what I'm focusing on, what your developer is focusing on, is writing the actual code for it. So how to get the data, how to process the data, and how to send it back. The everything else is actually generated for you and managed via this Maven plugin. So if I run this, hopefully it brings it a little bit faster. I really hate this to be slow because the server needs to run for me to show you the client codes. So when it is running, I'm going to show you quickly the OpenAPI client. The OpenAPI client is also quite similar. So let me show you in the presentation mode. So it also has a Maven plugin, which is pretty similar with a little bit different options. So it is still generating, but it's now generating a Java, and it is only generating the model classes and the client that is needed to call your API. And once you use this, the similar thing happens, and it generates all your code inside your target folder. And if you see, where is it? API. Sorry. So if you see, it's already generated the class that you can use to call your APIs. And if you have security applied to it, if you have specific custom stuff doing in your endpoint, all will be generated for you. And what it gives you at the end is write a very small 2 lines of code, actually Spring Boot application on a startup event. I am actually calling the provider API, which has an ID 3. So is my service running? Oh, service is running. So if I run this, I probably get the call done to this API, which is hosted locally, for example, now. And what we did to integrate the API or to call this API is write 1 line of code. The rest has been taken care of by the OpenAPI generator itself. As I said previously, there are different API clients available. So it is not only Java. So if you have a C# client running somewhere, you can also actually generate your code for that client itself. I'm going to show you the Angular as well as soon as this client runs properly. So as you see, it calls it. It also has a toString method automatically added, which shows me that the API 3, the provider 3 has a name and description like this. So that is for the API client. Let me show you the front end. Here I have to actually give a special thanks to one of my colleagues, Stefan. He helped me actually preparing all the content and code. And the way the OpenAPI generator is integrated in this is quite a cool way, actually. I'm going to show you the package.json of this. You can use the CLI inline as a npm run command to generate your API, generate your client. You need to specify, as I was saying, with -g, which type of client you are actually generating with some additional properties. But there is another way to do it as well. But before I go there, I'm going to show you what this does. So when I run this generate API, it basically creates a API folder inside my source directory and create all the clients there. The reason I'm going to show you is because it also creates the README for you. And when you generate this code, the README tells you how you can consume that code, which is pretty nice in itself, because you don't need to go through find blogs or some other stuff to know how you're going to use this. Where is my API? Come on. Wow, my laptop is so slow. Really? Okay, then I have to rely on the node module. Or, let me see. Come on. Oh. See, there is an API.
So I don't want to hurry you, but you have still, well, around 4 minutes left or so.
Oops. So it also generates, thank you. It also generates a README file for you, which you actually can use to check out how you can consume this. It tells you how to consume this, how to publish it, and how to use it within your API or within your project. Which you can also do is, which Stefan did for our project as well, is create a small script which will bundle it for you and add it as a library in your project itself. And then it will live inside your lib directory, and you can actually, from package.json, directly use it. So you don't need to generate every time your code. So if npm within this 4 minutes, till that starts up, I'm going to show you the regression test part as well. It's quite common that you have regression test sets running in your project, where you define cucumber scenarios. If this happen, given this, when this, you expect that. That is also quite useful with the generator. So here also I generate a native package for the client API. And in the regression, basically what I use is one line of code, basically 2 lines of code to invoke that. So the boilerplate code is actually bring down to completely 0 in this case. Well, let me see if my UI is up and running. No, UI is taking a lot of time. Last but not least is Postman. So for example, you have if you are used to checking your you are testing your API using Postman, you can also actually import the YAML file completely, and it will create the collection for you with all the different URLs, different parameters within it. Since I have very little time left and my laptop is not working with me today, I'm going to move on to my presentation. These all codes are in GitHub, so you can take a look at it when you spare time. Last is how you adopt it. So there are 3 different ways to adopt OpenAPI Generator. One is a GitHub way. So you have created a repository where you store all of your APIs and contracts. And then all the other consumers, your server, client, UI, testing, consume that as a submodule. So you add them as a JIT submodule. And then whenever there is a change, they can update the submodule and they have the latest change. The second way, they say it is a Maven way. So you generate your client, your server, add that as a dependency to your server or client, and use it from there onwards. The third part is, if you're not doing Java, the Node.js way, where you actually generate the stub, package it, and npm install it. So you refer it from your package.json. The third defined way, or the fourth defined way, is a Docker. So you host the Swagger UI in a Docker container, expose that, let the Swagger UI generate the code for you, and then you download that from it. So the picture you see here is actually generating a Ruby code and downloading it with another HTTP code. Who is using it? Quite a lot of people. You can check it out in their website. It's a big list, and there are some very huge names about it. Since I'm running out of time, I'm not going to go into this, but Swagger has a very nice blog about how you can approach the API first, and there are different steps you can follow to actually plan your API first program. So how you establish stakeholders, define your styles, implement the governance, and create a portfolio. I do suggest read about it if you are planning to do it, since 40% of us is not using this. So I definitely want to, if you want to start about it, definitely the place to start and read about how you get everybody on board on this kind of a scenario. With that, I have my presentation is over.
Je hebt talent. Je hebt idealen. Jij bent aan zet. Welke stappen zet jij voor de toekomst? Blijf je op bekend terrein? Of ben je een pionier? Volg jij anderen? Of word je zelf expert? Blijft het bij idealen? Of maak jij dromen waar? Scoor je zelf? Of win je als team? Welke toekomst creëer jij? Capgemini. Get the future you want.